Hola, hola, feliz día para todos. Soy el abuelosaurio matemático. El propósito de este canal es hacerle la vida más fácil a quienes estudian o están interesados en las matemáticas, incluidos los padres que quieren apoyar a sus hijos. Tú puedes ayudarme mucho a lograrlo si te suscribes a este canal, das like a este video y escribes en la caja de comentarios. Allí puedes sugerir temas que te interesen y trataremos dichos temas en próximos videos. También puedes ayudar compartiendo el canal en todas las redes sociales. This video is about a very simple explanation on the combination and permutation concepts. Let's have a singleton set. It only has one element, which is a girl. Let's do now groups of one with the elements of the set. Of course, this set only has one element, but we must form groups of one with that element. If the order doesn't matter, we can do only one group. And the number of groups is the combination. In this case, the combination is equal to 1. If the order matters, we can do only one group too, because there is only one element in the set. And the number of groups, when the order matters, is the permutation. In this case, the permutation is equal to 1. This is the only case in which the combination and permutation values are equal. Let's have a set of two elements now. And let's do groups of two with the elements of the set. If the order doesn't matter, we can do the first group with the elements of the set. Someone could say, why not to do another group with the yellow girl first and the black girl? But in this case, the order doesn't matter. So those two groups are really the same. They have the same elements. So we will discard the second one. The only group that we can form with the elements of the set is the one that is in the screen now. The number of groups formed when the order doesn't matter has to do with the combination. And the combination in this case is equal to 1. If the order matters, we can do the first group and the second group. Now we can have the two groups because here the order matters. And it means that the first group is different to the second group because the order matters. The number of groups when the order matters has to do with the permutation. So the permutation in this case is equal to 2. Let's have now a set with 3 elements, with 3 girls. And let's do groups of 3 with the elements of the set. Again, we will do it when the order doesn't matter. We could do our first group with the element of the set using the black, the yellow, and the red. Someone could say that we can do another group. But really, this second group is exactly the first one. both groups have the same elements. The difference is that they are in a different order. But remember that in this case, the order doesn't matter. So we will discard the second one, and the only group that we can form is the one that is in the screen. The number of groups that we form when the order doesn't matter has to do with the combination. So the combination in this case is equal to 1. If the order matters, let's see the groups that we can form. We can take the black and yellow elements and the red one and form the first group. Because the order matters, we can do a second group with the black, the red, and the yellow. We can do another group with the yellow, the black, and the red. But also, we can do another group with the yellow, the red, and the black. Remember that here the order matters. So each group is different to the other. We can do another group with the red, the black, and the yellow. But we can do another one with the red, the yellow, and the black. The number of groups formed has to do with the permutation when the order matters. So the permutation in this case is equal to 6. Let's have now a set with 3 elements. But now we're going to do groups of 2 with the elements of the set. If the order doesn't matter, we can form our groups with 2 elements. The black and the yellow, the black and the red, and the yellow and the red. These 3 groups has to do with the combination when the order doesn't matter. So the combination in this case is equal to 3. If the order matters, we can do our groups of 2 with the elements of the set in this way. The black and the yellow, and the yellow and the black. Remember that in this case the order matters, so those 2 groups are considered to be different. We can do another group with the black and the red, and another one with the red and the black. We can do another one with the yellow and the red. And finally, we can do another group with the red and the yellow. The number of groups formed when the order matters has to do with the permutation. So the permutation in this case is equal to 6. Finally, let's review some important ideas that we must take into account when dealing with combination and permutation. The groups in the combination, they are formed with the element chosen from the given set. And the same happens with the permutation. What about the number of elements within each group? They can be less or equal to the elements of the set. And the same happens with the permutation. What about the order of the elements in each group? In the case of the combination, it doesn't matter. And in the case of the permutation, it matters. That's all for this video. And remember always to be a curious person.